an array of bytes inside. This is just a pseudocode, let's call it. And then in the decode method, you could go and say decode file. You pass the file type as a switch or a case. And then if it's GEF, you do the code there, break. If it's JPEG, you do the code there, break. If it's a PNG there, you do the coding there. Okay. There is an advantage of abstraction. It seems a good structure. But the number of types could grow. Already the code could be very large within these if statements or switch statements. Therefore, this class become a huge class, very large class. And change will become difficult, maintaining is difficult, reusability is nightmare, etc. So where we go then? Any idea? Software engineers, I call them first. Computer scientists, cyber security. I think also the factory design pattern has got some sort of in cyber security, and the coming is also more useful as well in the relational design, the behavioral and the bridge and the adapter in a minute. Any idea where we move?
Would you move the switch into its own little class, so that way you can access it easily, but also make.
So what you are doing here, you are suggesting each one of these switches is you pass that content to that GIF class, to that. Yeah? Okay, good idea. Any more ideas? One way forward, I will create an interface at the top, yet it's design one rather than the most efficient yet. I will create an image reader at the top. Both the main methods I'm going to use in the subclasses. Then implement a class for each of these types. Good idea. It's good abstraction of an image reader. It's an interface, program to an interface rather than implementation. I mean, if you program to an interface, you could plug into the interface a lot easier and cheaper, because you are allowed in Java to implement as much as you can interfaces, but you have one opportunity to extend. Agreed? Okay, so interface is good. You've got subclasses here for the GEF, a subclass for JPEG, and so on. So now your reusability is a lot more. But we still have one problem here yet. Within the program, within the body of your program, interesting one, this is within the body of your program, you are doing the if statement, which is still this code going to grow and grow and grow. And each time, you'll need to test the input. Each time you are testing the input. Do you need to do that again and again? It's like these 200 lines of code here. They are redundant again and again and again in your program. Each time you want to decode an image, you'll need to go to copy and paste that large if statement. Is that understandable? Okay. And again, we're coming to the same problem again and again. These instances here, you are forced to put them in the body of the code again and again. The variables sizes again is being there in the memory. Okay. Design 2, which utilizing the factory design pattern, I'm suggesting to have a class called image reader factory, and within that class I define only, I'm not showing that variable n, but yes, image reader. I define only, look at that, it's there. I define only one variable out of the interface. Agree with that? Rather than many different variables. And when I want an instance, I'll go through this method, image reader, get image reader, and I pass the input. If it's GIF, this will return a GIF reader instance allocated here. and that is fine. If it's a JBEG, it will return the instance of a JBG subclass. The instance of its subclass. And the variable is only one variable created rather than 500 variables. Okay? Then I'm using that superclass variable in order to allocate the subclass instance to it. The subclass instance to it. Okay. Then things get more complex. Then the Java developers themselves, those used to work at Sun Microsystems, now working at Oracle, when they acquired Sun Microsystems, thought, oh, that's a great idea. We could build our virtual machine based on that. We could have a huge number of factories, but we need some way to organize this, because I will need not just one method, I'll need a set of classes, and this set of classes responsible for creating instances when needed. Okay. So they've looked at something called a bigger factory, called it the abstract factory. Obviously, that factory is going to inherit factories. So there is a factory at the top, and there might be a subset factory of that. That's a small example on that. A bigger example is you go through, this is going through the Java structure, is you go this. You've got a client, he wants to interact with the product A, product B. You've got at the top a root factory, and you've got a subset factory. And that root factory will have more factories on. So more classes responsible on creating instances of a group of classes. Okay, what does that mean? Most likely, this example will define it all. That is an example, a pseudocode of how the Java virtual machine is implemented. The example is looking at the option of creating buttons for two different operating systems and allowing you to see how this could be implemented. The abstract factory at the top here, we call it abstract class GUI factory. This will be inherited by two factories at this moment in this example, by the Windows factory and by the OS X factory. Why? Because they've decided, if I'm going to create GUIs for Windows, I'll put it in one factory. If I want to create GUIs for Macs, I'll put it in a different factory. So I'll need two factories rather than just one. Okay. Now, the end users, and obviously the implementation classes, there is implementations classes for creating a Windows button, and there is an different implementation class for creating an OS X button. Good question? Okay. So why do we need these two different classes? Because if you look at the Windows button when you load your application, a JFrame, it does look different than the OS X button you've seen for your application when you run it on the Mac. So these are two different classes, two different rendering, two different way of usage of these pixels on the screens, etc. And even the shape is different. So we need two classes there, 1 and 2. And to make it nicely, I have an abstract class at the top, so they inherit the button at the top. I'm talking only one button here, just to show you the example. So in the application, look at that. In the application, this is the application, how it's going to be utilized. The operating system doesn't know, or your application does not really know the underlying. So that is more or less what's inside the virtual machine. So say is there GUI factory, A factory equal GUI factory dot get factory. So, and this will come to the superclass. What does it say there? Check the operating system type. if it's, for example, system equals 0, which is a Windows, for example, it gives you Win factory. It returns to you this factory. And this Win factory is responsible on creating the Windows buttons. Windows buttons. So what is going to be returned as a result of that, when that factory going to create an instance of a button, it will return to you a Windows button. And the interesting part in the hierarchy as well, it returns the Subaru class. It's only used the Subaru class instance again within this factory. So more or less, this is a factory structure. This is a factory structure, and this is utilizing both. Does that make sense? Okay, that is really fun, because now you're utilizing the factory in a much more larger platform. Okay, now we are coming to the second part of the lecture. It's going to be a lot easier, this set of design patterns, and a lot simpler than the factory design pattern. These are the structural design patterns, which is mainly, they are there to be placed either how we integrate classes together, how we put them together, how we put objects and classes together, and emphasizing again there is another